Okay, now we're going to talk about theoretical yield versus the percent yield. Now, as I said to you the other day, when you solve a math problem, that is your theoretical yield. Okay, so your theoretical yield is the quantity of product that is calculated to form when all of the limiting reagent reacts. So sometimes it says when your reaction goes to completion. So your theoretical yield is the answer to your math problem. Okay, now we talked about the fact that your math problem always isn't what is actually made. Okay, and so to figure out what's actually made, you have to do an experiment. So that's going to be called experimental yield. So the percent yield is the ratio between those two numbers. It's the ratio of the actual or experimental yield of the product to its theoretical, which is the calculated yield, times 100, because we're going to get it into a percent. All right. So it's going to be how good were you? How successful was your experiment is what you're looking at. Because not all experiments are going to be created equal. And if your experiment doesn't produce a very good percent yield, it means you've got something going on wrong in your experiment. So I kind of think of it this way. When I conduct my experiment, if my answer doesn't come out to my percent yield to be a grade that I would like to have on an assignment, probably need to conduct my experiment again and try to control my experiment in some other way that helps me get a higher percent yield. Okay, so something's going wrong in your experiment if your percent yield doesn't come out to a good number. So I kind of think of it like a grade. Would I want that grade? If not, then I'm going to need to recreate my experiment because scientists want to have a high percent yield, which is your actual divided by the theoretical times 100. Now, you know, I always like to make stuff in alphabetical order if I can in your head. So that's how I remember which one of the two numbers goes first. It's actual over theoretical because A comes before T. So actual over theoretical times 100. All right. So the percent yield is the actual yield, which is they're going to have to give it to you because we're not going to stop on test day and perform an experiment. So they're giving you the actual yield somewhere in the problem. So you're going to need to read carefully because it's going to mean there are extra numbers. One of the numbers that they're giving you has to be your actual yield. All right. How am I going to get the theoretical yield? You're going to get the theoretical yield by solving a math problem. Remember, the theoretical yield is your math problem that you answered with our stoichiometry template. Okay, so the actual yield is what you get when you do the experiment, and the theoretical yield is what you calculated that you would get using your math problem. All right, so what is the percent yield if you obtain 30 grams of water from 27.3 grams of octane? Now you see we have two numbers here, and be careful because in the past that meant you were setting up two problems, but you'll notice here we need one of these numbers in every percent yield problem. One of the two numbers that they give me has to be the actual yield. All right, so you got to read into the question to see which thing is it that they're telling you what you actually made. See, it says you obtained 30 grams of water from this process. So the actual yield is this part here that's in green. Okay, so the actual yield is the 30 grams of water. So what am I going to solve for in this theoretical yield problem? Well, the only way that I can solve a percent yield problem and come out with a percent number is if both things are in grams of water. So both my actual yield, which is 30, and my theoretical yield have to be in grams of water because in the end, the grams of water is going to cancel out so that I can end up with just a percentage number. So that lets me know I'm going to be solving this problem in grams of water. Okay, so this is my given then. I've got 27.3 grams of octane. I always write down two things. I write down what I have been given and what I'm solving for. The rest of them I usually lazy myself out and I don't write all the units on everything else. So if they gave me grams, what goes underneath that? That is going to be your unit of grams, so that's molar mass. The coefficient of what I'm trying to find is water, so that's 18, over the coefficient of what they gave me, which was the 2. The units I'm trying to solve it in is grams of water. So that means I'm going to need 18. This 18 is from here. This 18, once again, is because you needed the molar mass of that. And then over 1. So I'm going to calculate 27.3 times 18 times 18. I'm at the end of the road, so I say equals, divided by, open parentheses, 114 times 2, close parentheses. And I end up with a number of 38.8 grams. This is the theoretical amount that I should have been able to make. Now, it told me I only made 30 grams of it. So if I made 30 grams, that's my actual over theoretical is my equation. So 30 divided by 38.8, and then times 100 is going to get me 77.3%. So 77.3%. You could also answer it 77%. A lot of times it is a whole percentage, but if it's an open-ended answer, we would use sig figs. There are 3 digits in both of these numbers here, so that would mean I have 3 significant figures in my answer. All right, so for the balanced equation shown below, if the reaction of 19.2 grams of oxygen produced 6.76 grams of water, what's the percent yield? All right, so if 19.2 grams of oxygen produced, so this is how much you produced, was 6.76 grams of water. All right, so I'm going to be solving this equation here for grams of water again, okay, because that's what they told me that they produced was grams of water. What did they give you? 19.2 grams of oxygen. So calculate the theoretical yield with oxygen as the limiter there. So given 19.2 grams of oxygen, I'm going to find grams of water. So when I get my answer, I'm going to get 7.85 grams of water. Then I could calculate my percent yield. It's going to be actual, which is the amount that they gave me in the question, always has to be given to me, over the theoretical times 100. All right, so to set up this problem, I set it up the same way. I had the 19.2 grams of O2, and grams told me molar mass. So molar mass of oxygen, that's where I'm going to get the number that I'm going to put here is 32. The coefficient of what I'm trying to find, what am I trying to find? H2O, so that's 8. Over the coefficient of what I was given, that's 11. The units I'm trying to solve it in is grams of water, so that's 18 over 1. So that would be my calculation, and that's where this 7.85 grams of water come from. So the answer to my question when I get finished is 86.1%. 86% if they ask you for it as a whole number. So 86.1 if they don't ask you as a whole number because of sig figs. Okay, so once again, the setup is going to be 19.2 over the molar mass of water times the coefficient of what you're trying to find and the coefficient of what was given, the units you're trying to find it in, which is grams of water, and over 1. So that's where this 7.85 grams of water came from. That is your actual, your theoretical. So actual came from the problem. It always has to come from the problem because the only other way to get the actual amount is to do an experiment. All right, so if you understand what's going on, go do your practice problems. Otherwise, let's do another problem. So for the balanced equation shown below, if the reaction has 6.02 grams of KOH produced, from 5.7 grams of KCl. What's the percent yield? All right, so this is what is produced, is the 6.02 grams of KOH is produced from this amount of potassium chloride. So this has to be the actual. So this is going to be the given. All right, so the given is, oh, I'm sorry. It says 6.02 grams of produce this many grams of KCl. Right? So they produce, I wouldn't even read my own words, produced 5.7. So this is the actual amount that's being produced, is 5.7 grams of KCl. So that means I have to figure out what is in theory, what is the theoretical amount that's being produced. And I'm going to solve it in grams of KCl because it has to be solved in the same units that they gave me the actual in. All right, otherwise I can't get a percent yield out of it. So the given number is 6.02 grams of KOH. Since they gave me grams, I need molar mass. The coefficient of what I'm trying to find is KCl, so that's the 2, over the coefficient of the KOH, which is a 2. The units I'm trying to solve it in is grams of KCl. So I went and looked up the mass of K and the mass of Cl. Remember, the mass of Cl is 35.5, but everything else we round to the closest whole number. So the K was 39. That's where I'm getting this number for the mass. I added up the molar masses and over 1. Then I can do some simplification here because 2 over 2 is 1. So I can do 6.02 times 74.5 divided by 56. However, you can let the calculator do your work and go across the top, say equals, divided by, open parentheses around 2 things on the bottom. When I calculate it, I say that I calculate 8 grams theoretically of the potassium chloride. So then I have to do the equation of actual over theoretical. The theoretical yield is 8 grams of KCl. The percent yield is 5.7 divided by 8 times 100, which is a 71% yield. It's 2 digits and 3 digits in my question. So they gave me a 3 sig fig and a 2 sig fig, which you always go by the lowest number of figures. It's 2 figures in my answer. So my answer is going to come out as a 2 significant figure answer. Okay, try the next one. Set up the next problem, calculate your theoretical yield, and then restart the video to see the correct answer. All right, so hopefully you read through the problem and you saw that the reaction of 8.3 grams, sorry, 83.3 grams of water produced a 31.8 yield. Okay, how many grams of oxygen would be produced? Okay, well, this one actually is a slightly different problem because they're telling you the percent yield, which means I need to know my I need to know how to solve this problem using algebra. I will need to calculate my theoretical yield, so I still need to know that piece of the puzzle. So my theoretical yield is 83.3 grams of H2O, and I'm solving for grams of oxygen. They had to tell me because they didn't tell me what we solved for here, except for in words. This is the yield of how many grams of oxygen. So that's how I know what it is that I'm wanting to solve for. So they said right here in the words, how many grams of oxygen. So that's how I know what I need to solve for. So the coefficient of what I'm trying to find is the oxygen over the coefficient of what I was given, which is the water. The units I'm trying to solve it in is grams of oxygen over 1. So theoretically, 74 grams of oxygen can be made. Now, this right here is the percent yield. It's not the actual or experimental yield. So I'm going to have to calculate an algebra problem, all right? So the answer is 74 grams for my theoretical, okay? And then I need to calculate the actual yield is what they're asking me. So plug what you know. You know the percent yield is 31.8. You don't know the actual yield. It's your X in this problem. You do know the theoretical yield because you just solved for it. So then you have to isolate this variable X. You got to isolate X and get it all by itself. So what's keeping X from being alone? Well, it's being divided by 74 and times by 100. So that means you need to times this side by 74 and divide it by 100. So you're going to have to first get the X all by itself. To do that, it's 31.8 times the 74 divided by the 100. That's what's keeping X from being alone. When I calculate that, my answer comes out to 23.5 grams. If you want to double check your answer, you simply put this number back into your problem. Put 23.5 grams as your actual, divide it by the 74 grams that you said, and then times that by 100, you were going to come out to 31.8% yield. Okay, so you can double check your answer when you solve your math problem after you isolate your X, because you have now all the pieces of the puzzle. Okay. So they're going to have you do one of those problems again where you're isolating the variable. So look through this problem and see, how do you know you already have the percent yield and that's not the actual? Units tell you. See, the percent sign on here lets me know I already have the percent yield. Okay, so, and they are giving me 57.8 grams of oxygen to find out how many CO2s, how many grams of CO2. So my theoretical problem has to solve for grams of CO2. Okay, so solve your problem. When you solve your theoretical problem, you calculate it out and you end up with 63.6 grams. Now I can isolate my variable, and when I isolate my variable, I find out that my number is 22.8 grams of CO2. Remember, you can double check your answer by putting the 22.8 back into your math problem here and solve. It should come out to be 35.8. So you're going to put in 22.8 divided by 63.6, and that should come out to 35.8%. This is an experiment that you would want to recreate again and do it more times, because having a 35% or 36% yield is actually not that great of a job. So something went wrong in this experiment to have such a low percent yield. All right, go work on your practice problems.